Yeah, hello guys. I think so my video is visible and I'm just checking on it live. Today we are gonna cover the rest of the two projects which we have done yesterday also, and right now also we are continuing that part because at the end there was some issue in the video, so I dropped the idea of continuing it. Nevertheless, we'll continue with the today's class. Okay, so we are gonna start with the project number 9. We have discussed project number 8, and before that we have discussed project number 7 also. Now the project number 9 is about wine quality prediction. Okay, support vector machine and decision tree. So what we have done, we'll just you should watch project number 8 before going for this project because most of the things yesterday I have taught, and this will be around 5 minute maximum or 10 minute maximum class. So I think so. Give me a second, guys. Something is going out of this loop. Do you guys able to just a second? I think so. Just you should watch. So we are gonna start with the project number 9. We have discussed project number 8 and okay, Sami, so is there with the mic. I'll reduce the I think so this is better now. Okay guys, so continuing with the part of the today's class. Yeah, so this is the basic import of the libraries where we are calling I thought I have discussed this absolute and relative one in the last class also. Absolute path where we give the exactly original path in context of your CPU storage or the where it is exactly stored in your account, whereas relative path is if both the data or one file is present in the next to it, another file in the same directory or the same folder, then we call it as relative path. So in this case, this is relative path. Relative path. So in this case, yeah, fine. So was just cross verifying that okay, my voice is audible or not. Okay, then we are just checking for the information of the part, the data frame. So we got to know there are 12 of the columns, including one of the column as ID. And over here we are having 1143 entries. And how many null values are there? No null values are there. So we are lucky in this case. And again, see, in the last class it didn't got recorded, but I have already taught the main concept. So if you guys got any kind of doubt, just put it into the comment or in the WhatsApp. So there is alcohol, our favorite, like most of us favorite point. Then free sulfur dioxide, total sulfur dioxide density, pH, quality. So in this case, this is the our target column, that is the quality. And we can see there is no object, so there is no need of encoding it or using the map function. Okay, so we are dropping the column ID in place is equal to true. That means key from the DF itself, we are removing the ID because in one of the R project, I didn't did it like janbooch ke. Okay, let's see how it's gonna result. But although the result was same, so but why to make your model learn extra things or make more complex? So better we will work to the point. Then we again after removing that, we check that that column is dropped or not. Yeah, successfully we have removed that column. Then we have used the box plot to check for the outlier analysis. So what we are seeing that yeah, multiple values are there which are over here. Okay, we are not the expert. Okay, is it possible or not? But still it is in the some range where the rest of the values is set. Means it is possible, highly possible. Then box plot of volatile acidity, possible. Again, citric acid one, I don't know is it possible or not. For residual sugar might be in some drink that too much of the sugar is present. So box plot of chlorides. Let's come to the main part now. Density. If you can see the most of the mean is 0.997. Density. pH is around mean is 3.3. Sulfates, alcohol. Over here you can see no box plot of alcohol cake. I think so that amount or something. So in the wine, I don't know what is the difference between both of them, wine and alcohol, but although it might be the presence of alcohol in the wine, I think so. So nearby 10.2 something. Nevertheless, we'll continue. Box plot of quality. we are having 3, 4, 5, 6, 7, 8, 3, 3, total 6 number of different values. Like quality varies from 3 to 8 in a scale of 3 to 8. 8 as the highest quality, 3 as the lowest quality. Meanwhile, the mean quality is between 5 and 6. Okay, then we plotted the correlation heat map to verify that, okay, what is the correlation? If you don't know correlation, just go back into the eighth one. I think I have taught in a better way. Again, one more time. Else you can check the basics somewhere I have taught. So better watch every video or better search on YouTube and what is feature correlation heat map and you will come to know. So yeah, so this is how box plot, sorry, feature correlation heat map is there for our, so density is increasing with the fixed acidity. Okay, and what is the alcohol and density connection? Density and alcohol, negative means if density increases, alcohol content decreases, or alcohol content increases, so density decreases. That is one of the, okay, and alcohol and quality is key. As the alcohol increases, quality also increases, right? In a ratio of 0.48. Okay, so we plotted the what are the different qualities. So we are having 3, 8, 4, 7, 6, 5. So maximum values we have of 6 and 5 quality, minimum values of 3 and second minimum is 8 quality high, like the topmost quality. So what we will do, we'll map every quality like 3 and 4 as low, 5 and 6 as medium, and 7 and 8 as high. So instead of bi-class, we are making a triple class. Earlier in the rest of the problems, we have done as a bi-class, binary class classification. This is triple class classification or multi-class, you can say. So yeah, so we did this mapping function and we converted the quality based distribution of the wine. So medium, high, and low. So high is having 7 and 8. Although 7 and 8 have less values, but if you sum, you will get nearby high. Okay, and medium has the maximum values. That's fine. Let's continue with the next part. Again, model training part. Over here, we are calling train test split. Sorry to inform, but again, I have already taught this in the last class of the project number 8, session project number 8. Right, so I should remove this. I should talk about this only. Then X train, X test, Y train, Y test, basics. Quality I have drawn because this is our target column. We'll be try to predict our, we'll tell our model to predict the quality based on the content of the wine, right? That is one of the better approach. And we are calling support vector classifier. So that is okay, fine. Accuracy score, classification report, and confusion matrix. So this is your classification report, this part, which I have called, but I didn't use in the last project. Basically, if you whatever your caller, just call upon, you just have to pass two things. That is your test, what you have written in your answer key. No, what is the actual answer present in the book, and why prediction is what you have written in your answer key. That accuracy score, classification report, or confusion matrix. Anything if you want to get, just pass the same matrix. Yeah, you'll get the output. So over here, what we are getting the accuracy is 86% or 85.5 to the confusion matrix look like this for the confusion support vector classifier. So first algorithm, second algorithm, we are calling it decision tree, random forest classifier. So decision tree, we basically know where is decision tree. We'll first talk about decision tree. So in the decision tree, criterion is again Gini. You change it to entropy and check how that is giving. If you don't know what is the difference between both, you go better check on the decision tree classifier website. Over there, you will come to know. Right. Then I again use the fit to train the model, model.predict to write the answer in this Y prediction, and we are just testing the rest of the part. So these three should be together. Okay. Now accuracy is 85% again, 85.15. In that SVC, that support vector classifier, it was 85.5. Over here, it is 85.15. Now, but in the random forest classifier, we got around the accuracy of 90%. And as you can see, this is the confusion matrix. So if you want to plot the confusion matrix also, you can use this, or better use the plotting method, where you can, in the last class, I have told about the different ways of like light blue, dark blue, which color you want to choose. And in the live class also, I have done one time for the different color of the confusion matrix, not confusion heat map I have done. So yeah, you can plot the confusion matrix. This is also one of the way. Else, if you want pictorially, what we have done in till the last project, you can do. So here our project number 9 complete. So that is around, I think so, 5-minute class mostly. Then we are going for the project number 10 now. So I'll, okay, let's continue. This is our data, how project number 10 look like. It's basically on the stroke prediction data set. So ID we have gender, age, hypertension, heart disease, ever married, work type, residence type, average glucose level, BMI, smoking status, and stroke. Okay, let's go back to the main IPONV file. And at the end, I'll tell you one thing which I have not done, and I want you guys to do it, such that you should also learn. So NumPy, Pandas, Matplotlib as usual, and label encoder I have used. Let's see why I have used. I also don't know. See, this is also I completed this project. I think so. Uh, Reveal in Finder. 13th of August. So I don't know what is inside this. So together we'll find it out. Relative path I have already given. So mostly you should give absolute path such that if you no, mostly you should give relative path such that if you share a directory to some of your friends or your project to some of your colleague, so better. In the last class I just did vice versa. Sorry. The answer is K. You should pass relative and properly given address of the relative data thing or whatever you are passing the file path. Reason being, absolute path no not necessary to be same, right? For here, if I share you this file and you try to run, over here you will get an error in the project number 8. If you're doing in your system for you, if you are the only person who is doing this, then definitely you should use. No, for the most of the time you should use relative only. Sorry. So but you can use absolute. Like both the thing, you can use whatever you need. But relative, what is the difference for the relative? What is the plus point of the relative? For example, if I want to share this project number 9, and if I share these two things to with you or this folder only. So if you run this in your system now, definitely without any issue, it will be running. Reason being because I have given the relative path. So it is the next thing present into the same directory or the folder. So that will help you. That's why we use relative path while sharing the project, or we are working if we are collaboratively working with multiple engineers. So no issues. Let's go get back to the job. Label encoder, definitely. So here we can check for the info. 4909. So some of the null values are there in the BMI also. Float 64 fine. Object are 5 are object. If you want to check, you can check. Ever married. Yeah, that's why we have used label encoder. Right. Gender and smoking status. So this is the list. So whenever you want in a list form, you use this. If you want in the index form, just remove this part. You'll get everything columns name in the index part. Right. Then we have ID. So we dropped it ID. Then we have another thing is gender, another column. So we want to definitely label encode it because it is one of the object column as well. So female is 2994, male is 2115. Again, better data, no need, not a too much imbalance, and other is 1. So either you can drop it or no issues. So this is a graph plot of what I have done over here. Then if you want to put fit trans, LE is nothing but your label encoder. Then I label encoder. So definitely now I have three values, 0, 1, 2, other as 2. So then ever married value count, yes and no. Over there, ever married LE, again label encoder, fit transform, ever married. What you want to transform the values of ever married? Where you want to store in this column name, like replacing the values. This is the replacing, not creating a column. If the column name matches with the pre-exist, so it will replace all the values what you are gonna do after this equation sign, like equal to sign. So ever married, yes, no. Values are little bit up and down, but it's fine. Def lead fit transform again, fit transformation done. So over here, if I want to do yes, no, by using map function, yes, I can do, but this is the part where I have used label encoder. That was the uniqueness. Another work type, we have value count as 4 or 5. So for me, it doesn't matter ki which is as 0 or 1 or 2 or 3. Basically, if I use map, I'll put children as 0, right? Then I'll go for private or self-employed or something like never worked as the last option. Government job, I might give you the preference as 4 or 5. So, or never worked 0, children 1, private 2, self-employed, government job 3, self-employed 4. So, yeah, from SQL under pre-processing, import label, why I used again, I don't know. Okay, LE fit transform, might be I have done it later. So, that's it. Work type, and I just use a label encoder to convert those values. So, what I got 0 based on the naming culture or whatever the value count. So, df dot residence types value count. So we are getting urban, rural, fit transform, fit transform, fit transform for the smoking status. Smoking status we have never smoked, unknown, formerly smoked or smokes. So I'm continuing because we know the part what is going to happen at the back end. So Isnal dot sum. So BMI have around 201 missing values. For this, we'll check for the skewness. I think so. I have to check for the skewness. Yes. Another great concept, guys. You should focus over here. I don't know what is the timestamp of the video, but over here you should focus. Plot dot distribution histogram I have used for the BMI, and edge color is black. Edge color bole to ye this color, right? So I got this one, but I have to check the skewness. So if you can recall AI Works class, I have already explained what is skewness. If your data is shifted towards a particular scale, like having a more value, for example, let's say there is a class of 75 students. Over there, only out of 75, 50 students are of age 0 to, not 0, sorry, 18 to 22. And meanwhile, the rest of the 20 students or 25 students are of the age 80 to 89. So what will happen? Ki your most of the value will be over here and a small peak also here around the age of 75. So in that case, you can say this is right skewed. Where is there is the tail, we call it that type of skewness. So tail is in the right side, so it is right skewed. So we check the skewness. If it is greater than 1, that means yeah, it is a right skewed. If it is less than 1, it is left skewed. Less than -1, sorry, if it is less than 0, that means it is left skewed, right? And that is negative skew. Definitely the value will be negative, less than 0. So if the value is in the negative, it's left skewed. Think of it like a real number line. Just a second, guys. So, okay. Then fill in, we are filling with the median. Okay, why median? Why not mean, brother? Whenever there is a skewness in your data, you should not fill it with mean. Means until unless your data is normally distributed. This is not normally distributed. Not normally distributed. This data is not normally distributed in the BMI column. So we are using median. If your data is normally distributed, bole to if the skewness is nearby 0, if skewness is nearby equal to 0, that means data is normally distributed. Okay, so normally whatever this is normally distributed. So in that case, we'll fill with the mean. Else in both of the case, we'll fill with median. Either left skewed or right skewed, doesn't matter. So we have filled with median. To check it more better, try to replace with mean. Okay, you will definitely check there is a difference between the everything. Whatever you will do, correlation will change. Check for the particular column for the BMI. No, these values will be changing because mean and median are two different things for a particular data. And over here we are having around 4,000 count of the data. That means definitely those two values will be different. So no issues. We'll continue with our. Uh, let's have a glance on this. Gender, age, hypertension, heart disease, ever married, work type, residence, blah 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 blah. Smoking status. Let's check smoking status with the stroke. Smoking status. Oh, guys, better you can smoke, no issues. I thought of like if you smoke, you will get more cardiac arrest. No, better. There is no issue in smoking, guys. I'm with you. Glucose level with stroke, yeah, there is slight increase, positive chance, but it is more related with the age. Okay, as the age increases, glucose level increasing. Right. Residence type doesn't matter actually. Work type negatively correlated with the age. Okay. Then we have to check what is work type, how it is has been labeled, right? Until unless we can't predict what it is there. Then ever married, yes and no. Age के साथ eh? Ever married, no. Okay, means as the age is increasing, chances of getting married is increasing. Nice. These are the common insights you can think of. Work type and BMI. Like leave the work type. Ever married. BMI and married. Nice. Nice, nice. Smoking status. Ever married and smoking status. Oh my god. Oh my god. Too good, too good, too good. Age 32, BMI. Nice. Positively increasing, positively increasing. Ever married increasing means no and yes. Yes, it might be one. So yes, BMI is also increasing. If 0 to 1 is there in change in 0 to 1, there is a change in BMI also. Smoking status. So, guys, what if we can conclude that getting married is more dangerous as compared to smoking. So, better you should smoke, not to get married. That might have, okay, let's check ever married and stuff. See, guys, see, there is high chance. Actually, 10, not 10 times, around 3 times, 3.2 times. Getting married is 3.2 times riskier than smoking to cause stroke. That is one of the key insight, guys. Better you should understand this. Let's train the model now. Okay, then I have taken stroke as the target column, and train test split again. We have splitted the data set. Okay, naive Bayes we have calling. Okay, I didn't saw which algorithm. That's what I was finding. Okay, where it is. So Gaussian naive Bayes we are calling. Fine, no issues. Then okay, classification basic metrics. So we got 87% of the accuracy. Okay, guys, so this is one of the good. Try using a random forest over here. It will give you better result based on the heat map what I'm getting now. If we tried it, definitely we will get above 92, 93% accuracy. So this is my personal thinking, right? My experience is telling, okay, you will get more accuracy. Okay, let's work with the last project. That is the project number 11 till now. And project number 12 will be your optional project. This is where we are gonna complete our project over here. So this is your homework project, guys. Heart disease prediction. In this, why I left it, I don't know why. Okay, this is your capstone. Let me see the data now. Then I come to know why I gave this as homework. Okay, let's come to the back to this. I called this. There is no null values. 5 object categories. That is gender, sex, chest pain type, resting ECG. How many? 918. Okay, now I got. Okay, this one data set. Guys, I'll tell you one thing. Come to the describe. Okay. Come to the describe section over here. If you can see, cholesterol. Can cholesterol index be 0 for somebody? No, but here it is. Okay, what is the resting ECG? 0, not possible. Fasting blood sugar? 0, not possible. Resting BP? 0, not possible. Although chest pain type can be 0 because these are the 4 different types of chest pain. ST slope 0, not possible. Like possible, but I have to check. I don't know. So, guys, it's now your homework. That's why I kept in homework. Now I realizing it. Okay, for this describe section, guys. Now your homework. Listen to your homework carefully. Now your homework is to make a machine learning model based on this data. What we have data number 11. Right, this is your homework project, and get a machine learning model. Use 4 of the algorithm, whatever you want, any 4. If you want another one which I have not taught, like XGBoost or AdaBoost or gradient classifier, multiples are there. So if you want to use that one, no issues. Just do use 4 algorithm and give me the output and get me one insight. Okay, how is this data and how you will deal with this type of data. Okay, guys, so this is your homework project. So here we are ending our today's class. I hope you enjoyed it a lot. If not, let us know, okay, how I can make it more enjoyable from the next classes. Now you will get the PDF, those who have completed till project number 11. Although I'll give you 2 days more time, or till Saturday you have the time, 24th of August. I know that was 7th of August, now it is getting shifted to 24th. It's fine. For me, it's fine. And for you guys, it should be fine because at the end you are learning. That was the most important thing and give you the one of the good learning what I feel from my end. I gave you 100% while teaching. Although there is some discontinuity between the classes. Okay, from the next time I'll try. This will not have happen. And okay, guys, soon feedback form will be given. Now, I would like you to complete all the 11 project. Again, deadline will be extended till 24th of August. Complete till project number 11, and those who will complete project number till project number 11, those will be rewarded with certificate. Else, no chance. Okay. And multiple requests I got. Okay, brother, can we increase the last date also? Because there is a class also I can understand. So okay, no worries. Although it's right now 20 August 12:20, right, midnight. So, okay, guys, take care. Complete this project, upload it on the Google Drive, and let me know. Take care. Bye bye. We'll see, meet you in our university soon. Okay.